Hi. We will continue to work on chapter 13 this week too. The last part of chapter 13 introduces the two special kinds of proof technique. One of them is called conditional proof, and the other is called reductio to ad absurdum, reduction to absurdity. These two techniques require some exercise to be familiar with. So that's why I will devote a whole week to mastering these two techniques. Okay. These two techniques are very useful for certain kind of arguments. If you do a proof without these, it may take, let's say, 20 steps to complete a proof. But if you use one of these two techniques, the proof may last only like 5 steps. So it's really convenient. So let's look at conditional proof first. Conditional proof, when do we use that? Conditional proof is used when the conclusion is a conditional statement, any conditional statement. Okay? So when the conclusion that you try to derive is a conditional statement, you use conditional proof. How do you proceed? Well, first, start by assuming the left-hand side of the conditional statement, and then try to derive the right-hand side of the conditional statement. If you can do that, then immediately you write down the conclusion itself and say, well, I've just derived the conclusion by using the conditional proof. Talking about an example, it will be the best way, I think, to illustrate the method. Here is an argument. There are 3 premises, and the conclusion is B, then D. So we can use conditional proof because the conclusion is a conditional statement. We number the premises. And according to conditional proof, I'm supposed to start by assuming the left-hand side of the conclusion, of the conditional statement, which is B. Okay? So what I do is I write down B. And I use indentation to mark off the fact that I'm starting a conditional proof. Okay? So it says assumption CP. Okay? I'm assuming this because I'm following a conditional proof. Now, once I've assumed the left-hand side, all I need to do is derive the right-hand side, which is D. Okay? I'm not trying to derive here B, then D. All I'm trying to do is derive D. Okay? That's the conditional proof. Okay? So step 5, I'm here trying to derive D. Eventually, I like to get at D, but I need to work with these 4 premises to get to D. If you look at number 2 and 3, there is something that I can derive. I can derive A from 2, 3 by using the rule disjunctive syllogism. Okay? Something or not C, and C is the negation of not C part, so I can derive A. Okay? Step 6. From 4 and 5, I can derive A dot B. 4, 5 conjunction. If you look at 1 and 6, you can derive C then D. 1, 6. Again, by using the rule disjunctive syllogism. Okay. Number 8. From 3 and 7, you can derive D. 3, 7, disjunctive, not disjunctive syllogism, but 3 and 7, modus ponens, right? So, and P. Now, what I've got so far is I have assumed the left-hand side and have derived right-hand side. Okay, so I can complete conditional proof at number 9. Okay, the step number 9 should be in line with these original premises. Okay, I have to get out of the indentation part, and number 9 says B then D. And how did I derive this? Because of step 4 through 8 conditional proof. Okay, that's how I do that. Okay, so you start when you want to use conditional proof technique to derive a conditional statement, you start by assuming the left-hand side of the conditional statement and derive the right-hand side. Then automatically you can derive the conditional statement itself. How? Well, that's what conditional proof guarantees. Okay? So from step 4 up to 8, okay, you have I have used conditional proof. So that's conditional proof. The second special technical proof is called reductio. Reductio is used for different occasions. We can use conditional proof only for conditional statement, but there is no such restriction for reduction. RA, okay, reduction to absurdity, RA, can be used for any conclusion, okay, for any conclusion. So it's a very general method. What do we have to do? We start by assuming the negation of the condition of the conclusion, okay? And then try to derive a contradiction. A contradiction is any statement of this form: a statement and its negation is called a contradiction. Once I derive contradiction, I write down the conclusion itself and complete RA. Okay. Again, we will use an example here. Here are two premises, and the conclusion is A. Okay. Number 3, according to if I have decided to use RA, then I follow the instruction, and the instruction says I start by assuming the negation of the conclusion. Conclusion is A, so I start by assuming the negation of the conclusion. Okay? Again, you say assumption RA. I'm using RA, and RA says I can start by assuming the negation of the conclusion. Now from 1 and 3, now once I have assumed the negation of the conclusion, all I need to do is to derive a contradiction. Okay? I will eventually get to a contradiction. But what's the next step? I look at these 3 steps and think about whether any rule can be applied to any one of them or any pair of them. If you look at 1 and, so you have to look at 1, 2, 1, 3, 2, 3. Okay? If you look at 1, 3, there is a rule that you can apply. And you can derive B from 1, 3, disjunctive syllogism, right? Now, if you look at 2 and 4, you can derive C dot, not C, by MP, right? So 2, 4, MP, modus ponens. This is a contradiction, isn't it? It says a statement and its negation. It's what's called a contradiction. So I have started by assuming the negation of the conclusion, and then I have derived a contradiction. So I have done all that RA requires me to do. So at step 6, I say the conclusion itself, A. I have derived A. Well, how? From step 3 through 5, I've used the technique called RA. So that's this is how you do RA. Okay, and as I said, it is really useful, at least for some arguments. Okay, it's really useful to use these techniques to give a proof. So try to make these techniques yours by doing exercises. Okay, so that's it for today.